Welcome to Study Loop.
19.97, so we have a circuit here with three capacitors. Initially, this is connected to 24 volts between A and B, and C1 is charged fully. And then we flip the switch to disconnect our external voltage source, and that connects C1, 2, and 3 together. And we want to find the charge and voltage on each capacitor after the switch gets flipped. So our initial charge that's stored on C1 is going to be C1 V naught. And you can figure out what that is as a number if you want, which we don't need because we'll sort of carry this through and you can put all the numbers in at the end. But so I don't know actually what the number is for this, and it doesn't really matter for our purposes. So this is the total amount of charge, and so the total charge on all of the capacitors has to add up to this. So to begin with, we should treat C2 and C3 as one capacitor because it's in parallel with C1, and then we know that the voltage across C1 has to be equal to the voltage across the equivalent 2,3 capacitance. And so that capacitance is, we get from the usual formula for capacitors in series. This is 1.1 microfarads. So now the final voltage across this equivalent capacitance and C1 have to be the same. And then because C2 and C3 are in series, the charge on each one of those has to be the same. Because all of the charge that goes from like the positive plate of C3 is taken from the negative plate of C2. And the charges have to be, if it's, reached equilibrium, the charge on the negative plate has to be equal and opposite to the charge on the positive plate. All right. So total charge C1 V naught is going to be equal C1 V naught is going to be equal to Q1 plus Q23 and this is going to be C1 V1 plus C23 V23, which we already know has to be equal to V1 because these are in parallel. And so then this leads us to finding that V1 is C1 over C1 plus C23 times our initial 24 volts. And so then just putting the numbers in for that, we find that this is 11 volts. And this is also going to be the voltage on the combination of 2 and 3. So now that we know the voltage on capacitor 1, we can find its charge easily, just from the definition of capacitance. So Q1 equals C1 V1. So this is 11.5 microcoulombs, which is not terribly surprising because its capacitance is 1 microfarad, so you just the number you get is going to be whatever the voltage is times 10 to the negative 6, and then a volt farad is a coulomb. Sorry, this is 11.5 volts. So now the charge that's shared between 2 and 3, and it's going to be the same for both of them. So this is equal to Q2 is equal to Q3 is C23 times V23, which we already know is V1, or 11.5 volts. And so then this is 12.5 microcoulombs. Yeah. And then I think we can fit it on this page. So then V2, again going back to the definition of capacitance, is going to be Q2 divided by C2. This is going to be 6.3 volts. And V3 will similarly be Q3 divided by C3. And again, Q2 and Q3 are equal and are equal to Q23. And so the voltage on 3 is going to be 5.2 volts. So C1, 2, and 3 have voltages of 11.5, 6.3, and 5.2 volts, respectively. And C1 has a charge of 11.5 microcoulombs, and C2 and C3 are both sharing a charge of 12.5 microcoulombs.